I'll fix that.
No.
Yes.
Do me like the thing yesterday.
No.
Why not?
No, it's not good for your learning.
Not at all. What?
So what's good for our learning?
We're actually about to talk about that.
No.
No, you don't. No, you don't.
What? Because every time I read what they're doing, I second guess myself.
Good, you need to be thinking through it.
I'm not second guessing myself.
Second guessing it? It requires you to think more.
I don't know. And then I gotta go. And I think
There you got it.
Alright. So,
That's right.
that's what I'm choking on. So no.
You choking?
Come on, bro.
Yeah, I'm choking.
really quickly, I want to remind you of this detail. First off, and obviously, like, y'all are the ones who are here, but if you're not here, it's really hard to learn. I got 28 students in this class, I got 21 right here, right now. If you have a friend that's just regularly not here or regularly tardy, please encourage them to be here. I know that there are struggles, and I know we have stuff going on outside of school, but you cannot learn if you're not here. Like, that's plainly put. We're going to talk about some other details with the classroom in general. Okay.
I did not take it.
Yeah, if someone didn't take it, then you have to do the retest. And if you didn't take it, you need to come talk to me so that I can give you a copy of the original test so you can use it to help you study.
I'm already under pressure and the sound are coming.
Yeah, I want to point something out here. So good, I'm glad that some of us are starting on test corrections. Like this idea right here, I don't think I will because I'm already under pressure and exams are coming up. Y'all know that the content on that test will be on our exam, right?
Dang.
Like, it's a 9 weeks exam, it's cumulative.
Everything gonna be on that.
Right. So,
I don't
if
think
you were
so.
struggling with this, I think that the test corrections, more than anything else, would help you prepare for that test. So it's something to be aware of. So that content will be there. Like, we spent almost 6 weeks on just linear, exponential, quadratics, and solving equations. So please make sure you take advantage of that. Also, in terms of the test corrections, things like that, please remember you need to come into tutoring at least once so we can sit down and talk about it. I had tutoring yesterday afternoon, as I do every Wednesday afternoon. I only had one student show up. It says 3:15 but I even stayed till almost 4:15 working with that student. I want you to be successful, okay? And we're going to talk more about that in a second. But please make sure you're taking advantage of your test corrections. Now, this is what I want to talk about for a brief minute. So we got 4 students saying not struggling, but let's see here. A little struggle explaining. Do practice problems at home? I'm not sure. Khan Academy, look over what we did in class. So these are things that we definitely can do, but I want to point out, these are things, like what I'm looking at right here is, it looks like these are things that y'all know that you're supposed to do, but my guess is that we're not actually doing these things outside of class. I can see how many people watch the YouTube videos, and I've got like 5 or 6 people here talking about watching YouTube videos. When I don't even have that many views, you know, taking the time to upload them and provide them as a resource, then you're not actually doing that, okay? So I need everyone to pause. I need all eyes up on this because I need you to hear this information. Eli up here as well. Okay, I need you to understand that, like, legitimately, I see your struggle and my heart breaks for the fact that you're struggling. There's no part of me that's likes the fact when students struggle. However, you gotta learn this content well. This information we're learning right now is still a holdover from Algebra 1. We didn't learn it well the first time around. And so we are learning things differently because it needs to actually stick. It needs to be useful. And I'm going to talk a little bit more about that in a second. But one of the things that I'm looking at is that it doesn't really look like we're doing what we need to outside of class to learn. One of the biggest things is the graphic organizers. I had a student yesterday make the comment, well, Mr. Kinney, I just have so many things I don't even know where to look. Okay, first off, everything in this class has a natural progression to it. And if you look at every assignment we've given you, or every summary, it's hole punched. So if you just take that sheet of paper and you put it in your notebook on day 1, and on day 2, the next sheet you put in your notebook behind that, it just kind of fills in. And it gives that natural order so that you can follow the progression in your notebook. That is something that I learned in college that I wish I had learned in high school because it would have helped me learn and study better. But if you just take the time to make sure your stuff stays in order in your notebook, that will help you because you'll see the natural progression instead of having random sheets of paper. The next thing is, yes, we have a lot because there are 2 parts of learning, and you got to understand this. A lot of us are trying to do stuff in math without understanding the concepts that go behind it. And we always start every unit off and every topic off with trying to learn the concepts, which is why we went to Desmos. I need you to take your headphones out, please. Which is why we learn the concepts and learn the fundamentals first, and then we put them into practice like we've been doing, where we identify the transformations and equations, we identify the parent function and the transformations in a table and write the equation. So, but all of that is based on the fundamental understanding in the background. Well, that's why I also ask you to do those graphic organizers. And even those of us who are doing the graphic organizers, what I'm consistently seeing is we are just writing down single statements that we gave at one point in time to you instead of looking at all of our concepts and all of our notes. Because when we talk about transformations, and this is something you need to think about, are transformations only seen in equations? No. Where else are they seen? Graphs, tables. So when you write about transformations on your graphic organizers, should you only refer to the equation? No. Should you only refer to the graph? No. Those graphic organizers are designed that if you take the time to go through your notes when the assignment or when the concept is assigned, then you are able to make connections across things. And when you make those connections across things, you're going to learn the ideas better. And I know that my class is hard at times. And I know that some of us are struggling to understand how I've set things up. And so I want you to hear this because I'm going to remind you of what the design behind my class is. Because I had a student in third block say, well, Mr. Kinney, I just can't learn the way you teach. Here's what I need you to understand. What you are more than likely used to when it comes to learning is a teacher tells you exactly what to know. You write it down, and you study that thing to know, and then you just reproduce it. But that's memorization. What I'm asking you to do, the reason I'm asking you to actively collaborate instead is, well, first off, let me ask this. What is math? And I feel like we've gotten away from that understanding. Math is the study of patterns and relationships. Do you need me to tell you every single pattern, or could you go explore it? Have y'all explored patterns and relationships? Have you discovered them? Yes. Right? So we study patterns and relationships. That's the first part of mathematics. And I gotta say this, I want you to hear me very clearly. As a class and as students, I think y'all have developed really well in the study of patterns and relationships. You've gone and you've discovered them. Okay? However, the next part, we study them, then what do we do with patterns and relationships? Study and then describe. And we are struggling on the describing and using our words. and I need you to hear me, if we're not able to describe those patterns and relationships, we don't fully understand them. That is a hint to you that, hey, and I'll say this, some of us are great at describing them. And I saw it here that someone was saying that we're still struggling with just explaining things. If you're struggling with explaining it, first off, get out of your head, just tell me what you're doing. Tell me why you're doing what you're doing. That's the first thing. Second, if you can't explain it and you don't fully understand it, that may mean that you need to go back to the graphic organizer or back to the original notes, which goes back to the idea of organization, to study the fundamentals leading up to this point. Because the fundamentals that Miss Courtney taught when she did her lessons have not changed whatsoever. If you still can't figure it out from your notes, then come into tutoring or watch the videos or do something to be productive. As I said before, my heart breaks when you struggle. It does. I don't like that. But I also know if you don't learn it deeply, then I've wasted your time. If you don't learn it deeply to be able to use it and generalize it and make connections, then I've wasted your time. And that's the other part about my class that's harder is I'm not asking you to just reproduce and memorize. I'm asking you to make connections and recognize these things in different places because again, what you will have to do for the rest of your life, by the way, I do want to point this out. How many of you think you're going to have to use these transformed functions for the rest of your life? No? No, Brittany? Not going to use them? Anthony?
I don't know.
I don't know. Soraya? No? I need you to understand, I know that for the most part, most of us aren't going to use this pure math side of things. But what you are going to have to do is learn how to look for connections across ideas. Whether you're in history, or whether you're dealing with history, whether you're dealing with math, whether you're dealing with English, whether you're dealing with any subject or any job, you have to be able to look for connections. That's why I've set the class up the way I have. It's not just about learning this content right here and right now. It's about helping you develop skills that are useful long term. And so I need you to trust me, but I also need y'all to work maybe a little bit more outside of class or ask those questions when we first have them, because I'm having students say, well, Mr. Kinney, I don't understand this detail, and it's like 2 weeks later. I need you to ask me originally. And I need us to make sure that we're making these summaries. Before I continue the next part, what are your questions about any of the stuff I just discussed?
Oh, we got another one?
Okay? So transformations, this is the summary, okay? We need to recognize a lot first. Under a summary, with transformations, does anyone see a detail that we should write down first? And like, I want you to understand, none of this is new. This is putting it all together, which is what the whole point of the graphic organizer was. What's the first thing we should probably write down here? I see a critical detail up here.
Vertical and horizontal.
That's important.
First, identify what the transformation is.
Every time, what have we said that you have to do first? Identify that parent function. You got to. If you don't, you're going to be in a bad spot. It's going to be hard. So, ID parent function. And what's going to help you have the best understanding of that parent function to be able to work with the transformations?
No.
What do you need to know about that parent function?
The equation?
The equation. What else? Is it just equations? Is that the only thing that matters? The graph and the tables. Remember, if you have all three, you're going to have a better understanding. So ID the parent function in equations, which remember that's our algebraic, in a table, and graph. You need to look for all three of those. Is any of this brand new information?
No.
No. Was this concept on the graphic organizer, the big ideas graphic organizer? Yes. So like, if you take those seriously and you actually use them to study, this can help you significantly. Right? So ID that parent function in equations, tables, and graphs. Do all three of them. It's going to help you have a better understanding. And remember, you don't have to memorize any of that. In fact, I never would memorize this because it's a lot to memorize. There's a lot of parent functions out there. But if I know the equation, how can I get the table and the graph for that equation?
Plug it over
Plug
in.
in numbers.
Plug in numbers, right? You don't have to memorize stuff, and I think we're getting better at that, right? Make sure you have good x values, but then you substitute it in and get those y values to have your table and then your graph. But ID that parent function. What's the next thing?
Identify the transformation.
Identify transformations. Now, this is where we're struggling, I think, because we're not making important connections and we're not thinking through all these details. First off, transformations is the big group idea. But also, what mathematical representation do we see transformations in?
Addition and subtraction.
Mathematical representation.
Oh, equation.
A graph. A graph.
Oh.
I need you to remember, we can use something in equations to figure out what the transformations would be, but we got to recognize that the transformations are seen in graphs. When we talk about a translation, we're talking about moving the parent function, aren't we? Yes, very much so. And that's why you have to think across these different representations. So what are the possible transformations?
A translation.
Translation.
A dilation and a reflection.
Any questions up to this point?
No, sir.
Any of this brand new information?
No, sir. I've been spelling dilation.
Yeah, a bunch of y'all doing D-I-A, and that's not how you spell it, D-I-L.
I'm just spelling everything wrong.
Y'all best be glad I don't count off for spelling.
No, I'm just spelling how it's
Okay.
sound.
It's dilation.
I said dilation.
It's not dilation, it's dilation.
Oh.
Dilation. Alright, but again, these are transformations, so where are these seen?
On graphs.
On graphs,
Yeah.
right? Okay, but what if I have an equation, or if I have a table?
You can see it on equation. On
How?
What did you just do?
How do I see a translation in an equation or a table?
In
Graph-
a
the main
table, you
operation.
just see
Graph-
from, how did it get from the x values from the parent function to the new transform?
I would agree with that. So, well, let me pause for a second. Can we graph it? Yes, and we can find it that way. But what I'm asking you to help you write equations, things like that is, but how do I know, looking at from the x to the x, how do I know when it's a translation? What causes, say again?
subtraction and addition.
Ah,
Yeah, addition.
so we need to be looking for addition and subtraction in tables and equations. So if you see multiplication, are we talking about a translation?
Yes?
No. No. Wait, what did you say?
Oh,
If
no,
we
no.
see multiplication, are we talking about a translation?
No.
It's either a dilation or reflection.
You know how many of y'all I saw talking about this being a translation down to
No, that's a vertical dilation.
and?
Reflection.
Okay. We need to be aware of that. That's not brand new information, but we need to slow down and think through that if it's addition or subtraction, that's the only time it's a translation. So what about dilation? How are we going to see that in tables and equations?
Multiplication. By a positive number.
Yeah, probably.
Now it can be a negative number, it's just if it's negative, it's also a what? Reflection, right? Which remember, this is why we talked about dilation. So in general, multiplication, which remember that can be division, we just want to write it as multiplication. So a dilation, or it's multiplication and it's,
Smash division.
when is it a stretch? Well, and so remember, we're just gonna rewrite our division as multiplication. So if you wanna make that note, rewrite division as multiplication. But how do we know when it's a stretch? Remember, a stretch again is part of the graphical representation.
One's bigger than one.
When what?
When the
It's
number's
bigger
bigger
than
than one.
one.
What number?
0, well, 1.
Something is bigger than one, but this is again where we're having issues.
L.
The absolute value of
L.
f. And remember, the absolute value is why I say it can be positive or negative. That's going to force it to be positive, right? What do we mean by f, though? Factor. Because what do we do with factors, y'all?
We multiply.
Oh, yeah. So a dilation deals with multiplication. That's it. It's a stretch. If the absolute value of f is greater than 1.
Then a compression is less than 1.
No, sir. That's partially correct.
Oh, 0 and
Between
1.
0 and 1.
It has to be between 0 and 1. And again, notice it can be a negative in between 0 and 1. The absolute value would be between 0 and 1. It just has to we just have to make sure that we recognize there's a reflection as well. By the way, I ran out of room, but we want to point out that the multiplication, the stretch, and when f is greater than 1 and compression is between 0 and 1, that's seen in what representation?
Dilation.
No, what representation?
Somehow, who's on the right?
Do we see the multiplication in the graph?
No, equations.
Oh,
This is again in equations and
Table.
tables. What do we see in graphs, right? Not the multiplication, but the
Dilation.
dilation. Remember that stretch, again, the stretch and the compression, stretching or compressing, that's in the graph. I just made the separation for if the factor, what you're multiplying by is greater than 1, then I know it's going to stretch on the graph. But notice, like, you have to recognize how all these things are connected. What about a reflection?
multiply
by
by
negative.
negative.
Okay, now I want to point this out, because, and I should have really said this here. Yes, multiplication, right, by a negative, but we want to remember, what do we mean by multiplication? Because this is something I saw a lot on the graphic organizers, and it hurt us on the understanding check. Well, no, sorry. When I say multiplication, what is being multiplied?
A negative factor.
Well, sorry, I'm not being clear with this. What are we multiplying by a negative? What are we multiplying by this factor?
You
So-
said in the table?
So in a table, we would be multiplying the x or the y values,
Right.
right? Notice that goes back to the tabular idea. But in an equation, we're going to multiply the x or something by a value. And we got to recognize that there's a difference, and we got to be clear with that difference, that when we're talking about multiplication, we're talking about multiplying the x values or multiplying the y values by those things in tables. And that's what's creating those dilations in the graphs. Multiplication, we're talking about multiplying the x values and y values in the tables, and if there's any multiplication by a negative in the equation, then it's a reflection. So multiplication by a negative in tables. And so remember in the table, and that's, I should have added this detail right here, we're talking about x and y values and equations. So anytime we're talking about adding or subtracting in tables or multiplying in tables, we're talking about multiplying the x and the y values. Okay, so I see a lot of that information here. I'm going to scroll up and down in a second. But does anyone see any information that we are currently missing from this summary?
Mm-mm.
So I do.
Vertical.
Talk about
Horizontal and vertical, right?
the definition.
Notice right here, and so remember, these are the types of transformations. But can we just focus on the types?
You know, you gotta focus on everything.
But what else is there to the types?
Horizontal.
Horizontal and vertical, the direction as well, right? And we see some of this information up here, right? Anytime we're talking about a horizontal transformation, it affects which values?
X.
So we also need to include a direction in there. So horizontal transformations, one, they affect x values. Where do we see the idea of affecting the x values? Which representation is that in? In graphs and in tables?
And
Do we see it in equations? Like, do we actually see the x values being changed?
No.
Uh-uh. So we're gonna talk about that in a second. So affecting x values in tables and graphs. And this is an important detail about horizontal transformations. A lot of us were missing on the graphic organizer. How do we see it in equations? And this messed us up on the understanding check as well.
What, how we see a horizontal?
Inside the main operation.
If, now, and so remember, we do want to say inside the main operation, but if what's inside the main operation?
The horizontal
X.
But how do we see the transformations in an equation? Because I don't see translations, dilations, and reflections in the equation. So that it is with the x, say again. So, if adding, subtracting, multiplying, or dividing inside that main or defining operation, let's just say add, subtract, multiply, divide inside main operation creates, or main operation in equation. There we go. Right? Horizontal transformations occur if we have addition, subtraction, multiplication, division inside the main operation in an equation.
And it flips and when it's in the inside.
Be careful of that language, we're going to focus on that in just a second. But again, I want to emphasize, is any of this new information?
No.
Nope. For those who have done the graphic organizer, at least looked at it, even if we didn't fill it out perfectly, is all this, are all these concepts on that graphic organizer? Because you have summarized all of this pretty well to help you study and focus your attention? That's the big thing with that graphic organizer, is it's supposed to help you focus your attention as we work through these things and give you notes about which lessons to go back to. And so what was Anthony saying that we do need to be careful about and remember?
Until the inside is the inverse.
So the horizontal transformations, right, so those operations, let's say horizontal transformation operations, act the inverse in the equation, but only in the equation.
Now, vertical translation.
Well, before we get there, I want to point this out because yesterday, on that absolute value function, on the tables, saw a lot of people tell me that it was horizontally stretched by 2, which it was, and then they wrote this equation. Is that a horizontal stretch by 2?
No, that's a vertical, that's the, horizontal dilation.
It is, but remember dilations can be stretches or compressions.
But
What's
then
the factor here?
it's a positive.
Huh?
It's a positive too.
The factor here?
Two.
There,
It's not a 2.
it's inside the main operation.
It's inside the main
There
operation.
isn't.
There is a factor.
Is it on 1/2?
Thank you. Why is it 1/2?
The reciprocal.
Oh.
Because it's the multiplicative inverse. Is that gonna stretch by 2 then?
No, that's a
If you're multiplying by 1/2, is that gonna make a number bigger or smaller?
big or smaller.
That's a compression. Remember, I wrote this as F for a reason. If F is between 0 and 1, we said it's a compression, right? Remember, y'all all said, or at least Anthony said, and then you got right away from it, you know the simple fact that it's the inverse horizontally, right? But you gotta slow down and actually apply that. That's not applying the inverse. If it was a stretch horizontally by 2, I shouldn't be writing a 2 here. I need the inverse. What's the multiplicative inverse of 2?
1/2.
That's what should have been right here. Remember, it's in the equation that's the inverse. That would have stretched it by 2.
But if it's a compression by 2,
Well, it'd be a compression by 1/2.
by 1/2, we put 2.
Correct. Because you need the multiplicative inverse. Okay, we're almost done with this summary. Just looking at our answers up here, I think Anthony's right, the last thing we need is vertical. What should we note here?
It'll place the y-axis.
Say that one more time.
It'll place the y-axis.
Does anyone want to push back on that language?
Value.
Remember, you can't change the axes. It can affect the y
No,
values axis.
Oh.
And same thing Anthony did.
You sure can't change.
Correct. Uh-huh. So addition, subtraction, multiplication, division are where?
On the outside? Of the amendment.
Don't forget it's in equations. Everything we've learned in the last 2 weeks could have been summarized in 1 page. That's not an overwhelming amount of information. We gotta learn it. We gotta learn it deeply and well.
Yeah, that's why it's taking us so long, because we dive deep into it. Deep.
We've been diving deep, but we haven't learned it deeply. That's the difference.
They feel like it.
Some of us have learned it more deeply than others, but even you, Anthony, like, you're not slowing down. You told me point blank that horizontal transformation operations act the inverse in the equation. And then as soon as I talked about stretching it horizontally by 2, you didn't recognize the inverse, right? We need to actually understand and apply these things. These are things that you have to know off the top of your head. And I know it's a lot, I get it, but it's also, you have to actually learn it for it to be useful. And we're trying to make those connections across things, and learning is not, learning it will not happen if we just do the bare minimum inside of class. We gotta work outside of class too. What are your questions about any of this information before we continue? Is Chicago saying nothing? I'm waiting for you to think. All that's good. So, you have the homework assignments that are due tomorrow, which you should have the majority of it done. Do you know what I'm referring to? That's one of the things kind of gets. So, this is the transform functions practice 3, where you're giving graphs and you're going to equations. That's due tomorrow.
Oh, that's the homework?
The other thing is, this packet where you were given equations and you had to identify the transformations and the graphs and tables. And there was one more where you were given tables and you had to make equations.
So I did.
What is it?
That one that Anthony has in his hand right there.
This.
No.
That's not it.
That's not it. I was thinking it's probably
You got this one done?
and this is the last one, where you are given the tables and you have to make the equations. These 3 assignments are due tomorrow. You should already have this whole page done, or this whole back page done. You should have the majority of this done and all of this done already. So it's not a ton, but we need the practice, and I need to see what you have so I can give you some feedback and what we may need to work on next week in preparing for our 9 weeks exam.
I'm gonna say all the other ones.
I think first and second are on Friday.
And it
What was that?
First and second and third day is second and fourth.
I will say this, be on the lookout, be on the lookout for an email from me today where I include a Word doc of all of these assignments so you can clearly see what is due tomorrow. I think that will be helpful. Is
I
that
don't
fair?
think you have my email list anymore.
I think you are probably correct, so let's get that
Because I
fixed.
haven't been getting them.
Well, let me remind me of that at the end of class, I think that's fine. Okay, so, again, hopefully we have a good, strong summary of everything that we need to know and go back to this. But I want to emphasize, I want to remind you, none of this is new. All of this is stuff that we have learned and we have talked about over and over again over the last 2 weeks. Use your resources. Today, alright, so I'm going to talk a little bit more in a second about the summary here. Today we're going to get into this activity 2.1. We're actually going to learn how to transform functions by non-constant values. What we've been doing is transforming by constants, meaning adding 3, multiplying by 2. So what do I mean by non-constant values?
Different rate of change?
There might be different rates of change, but if we have different rates of change, we're going to be including what would be the opposite of a constant. So not a 2, not a 3, but there would be a, well, a -2 and a -3 would still be a constant. Say again? So even a decimal would be a constant, 2.1. So I like these ideas, keep going. But 2.1 would be a constant, huh? Fraction would still be a constant.
Oh, yeah, I don't know.
Let me ask you this, what is the, just pause for a second, what's the opposite of something staying constant? It is what?
Not.
Think, good, yes.
Yeah, we know that, but like.
What do y'all think we mean by constant? It doesn't what?
Change.
There we go. So something that is non-constant is going to,
Say the same.
No, change.
it's gonna change.
Oh.
Remember I said,
said.
so, I asked what is non-constant?
Oh.
It means it's going to change. In math, what do we algebraically use to represent things that can change? X, variables. We're going to be transforming with variable expressions now.
So
It's not bad. Hold on.
This
We've
better.
learned it before. Okay, we've actually learned this before. We need to make connections. But before we get into that, I do want to point this out. This is your graphic organizer, parent functions. Give examples, non-examples. Pick 1 or 2 parent functions to show connections and relationships among mathematical representations. That's this first statement up here. That's the graphic organizer. And we only said this, but I was asking you for examples and non-examples. And so like, if you give this equation, make the graph, make the table to help you study. Identify the lesson or the sheet of paper where you go into more detail about parent functions so you can study if you need it. Translations. Clearly connect with mathematical operations and in multiple representations. Translations. We said it's in graphs, addition or subtraction in tables and equations. Right? This, and I would give examples too, but like this was designed to help you define these ideas and to explain them and reflect on your notes. The graphic organizers are designed to help you grow and learn. Please take them seriously. Alright, notice we go all the way through horizontal versus vertical transformations here. They're there to help you. Take them seriously. So, objectives. Nope, I forgot to get rid of that. This is what we're looking at. So, first off, you need your textbook out. Hopefully we remember to grab it. We're 2 days later than I planned on this being. Does anyone not have their textbook with them? Show of hands if you don't have your textbook with you. By the way, you need to be on M1-141 in the textbook.
It was the one week that I'll take it out.
I see on email to say, hey, you need it this week.
Well, I can't say something about
Yeah,
that because I'm not in any.
There you go, yeah.
You said what?
M1-141 is the page you need to be on. Anybody else not have their book, so they need a copy of paper? Okay? M1-141, yep. 141, not 141, not 41. M1-141.
M1-140.
You should see lesson 2, I think a page or two before that would be learning goals. Actually, I guess you need 139, I'll show you in a second. But look, here's what we're looking at. We've talked about translations and dilations, correct? Been looking at those? But now we're going into non-constant values to create higher degree functions. We're looking to describe the relationship between linear factors and its zeros. By the way, what's another word for zeros? Because this will come back up. Something we learned last unit.
R1.
So we talked about those zeros with R1 and R2, so we're talking about the
X and
roots or the
X.
x-intercepts. All those words are connected. We're going to describe how linear factors of a function combine to produce intervals of increase and decrease in the product function. Why is this going? Sorry. And then we're going to get into some of those other things in a second. All right. This first part, there we go. This is on, actually, I think a page or two before M1-141. What page is this on? M1-140. Go there first. If you don't have your book with you, then you'll just have to pay attention as we go over some details here. I'm going to work through this with you, but M1-140, this is called the getting started of this page. 141, not 41. That's why it doesn't look the same. Okay, so what we have here is as a functional transformation. Consider the constant function f of x equals 3. First off, Kelsey, any guess why we call this a constant function?
Because it has constant. It's
What-
repeated.
Okay, but what do we mean it's constant?
It doesn't change.
It doesn't change. No matter what is the y value for this function?
0.
The y value is 3. Remember, isn't f of x
Oh.
my y?
Oh, yeah.
So the y value is always 3?
Yeah.
So look at the graph on your book. There's a line, isn't there? What does every point on that line have in common?
They on the y-axis.
Not on the y-axis, because here's the
It has
y-axis.
a y value of 3.
It has a y value of 3. Every point there has a y value of 3. That's why that line goes with this equation. What are your questions? I mean, Anthony, you can see it. This point right here,
Yeah.
that's 1, 3.
Yeah, we been learning that.
I know, so why are you saying what?
Cause like, you said it, I don't know.
Okay, what are your questions before we continue with the next part of all this?
Nothing.
Thank you, Kyle. Eli, you good? Destiny, you good? Tired? Recall that you can translate this function vertically by adding a constant. That's what we've talked about, right? We've been looking at this idea of translating. If you add or subtract tables and graphs, and that's one thing I want to point out, only with constants will it translate it up. But now, what we're looking about is a transformation in which the d value is not a constant, meaning it is a, what is that? So a variable. Right. I just want y'all to recognize that it's a variable, because a variable can vary, so it is not constant. This would mean that the y value of every point on that line is translated by its corresponding x value. I want you to think about that. Literally, and there's multiple ways to approach this, but if I'm looking at 3 plus x, I'm adding what value? x. Do each of these points have an x value to it?
Yeah.
Yes? So, consider the point of the original function at x equals 1. This point has the coordinates 1, 3. Plot the location of that point after a vertical translation of x. Well, here's 1, 3. If we translate it up by x, what does that become? 3 plus 1. So that becomes the point 1,
3.
that was 3 plus 1.
4.
That's 1, 4.
Cause you added.
Because you added the 1, which is the x. So this becomes 1, 4. All I did was, I took the x value of that point, right? And I added it to the 3. What are your questions from there? This point?
3 plus 1.
Oh, you
So-
put it on the ground.
Remember, they said, so they said after a vertical translation of x, so we're taking the x value of this point and adding it to that 3. So 3 plus 1 is 1, 4. So, I want you to take 45 seconds, talk with your small group to do number 2. Consider the point of the original function at x equals -1. This point has the coordinates -1, 3. Plot the location of that point after a vertical translation of x. So here's -1, 3. Where would that point go? 45 seconds. Figure out where that point would go.
You don't have
Well, you're doing that vertical translation, right? It's -1, 3 to start, so where would it end up if we're adding the x to that 3? Can't do what? What are you trying to do?
-1 plus 3.
There you go.
That's the x.
Remember, you're starting at 3, and then you're adding the x to it, right? It's a vertical translation of x. So it'd be 3 plus what? What is the x value? Not for -1, 3. Hey. Remember, we're looking at this point. Right, so it'd be 3 plus, you be careful. What's your x value? And the y value is what?
3.
But I thought you translated it out x. Dawson, what'd your group come up with for this point for number 2?
3, 1.
3, 1? Okay, how did you get that point?
3 plus -1.
So 3 plus -1 gave you 3, 1?
You gave me a 2.
Okay, so that gives us 2. So how did you get 3, 1? Okay. Does anybody want to push back on this at all?
I got it 2.
Or add on to it, huh?
I got it 2.
You got a 2 as well?
Would it be 2,
So,
I just
What
don't
was
want
your-
over 2.
I said, would it be 2 and 3, like 2 and 3?
2, 3?
It's 2 comma something.
2, something?
0, 2.
It's -1, 2.
-1, 2? How did you get that, Anthony?
Cause, you keep x's as the same.
Okay, why are you keeping x the same?
Oh, because your vertical is the only thing changing.
Oh, it was only a vertical translation?
Okay.
So what's the x supposed to be?
-1.
-1, oh, okay. So -1,
2, like I got 2 right.
so, but we got the 2? But I want you to notice, it's only a vertical translation, so should the x change?
No,
No,
Wait, why you do it right there?
I haven't done it yet.
Oh,
it's supposed to be a line on.
-1, 2.
Yeah,
okay.
but, I had did my line on -1. My straight line on -1.
I don't know what you mean by that, hold on to that.
Alright.
What are your questions about number 2 before we continue?
I got it.
Like, I want you to notice, we originally had the point -1, 3, right? And what they actually asked us to do was to take that number 3 and add, add x in general, And what was the x here?
Negative.
Negative 1. So the negative 1 stayed the same, but 3 plus that negative 1 was 2. Plot other points after applying a vertical translation of x. What function is formed by translating all the points on the line of f of x equals 3 by x? Well, let's say I look here at 4. So I've got the point 4 comma 3. And so I'm just picking a point. Notice I'm doing all my horizontal points as green, the other ones are blue. So what point would that become, Aaron? Do you know? Like after I translate 4 comma 3 by the x value? Not sure? Okay, let's do this then. 30 seconds, talk with your group, try to figure it out. You don't have to write it down, just talk it out, try to figure out what's happening.
Figure out what?
Question again?
Say it, yeah, ask me.
If I have this point 4 comma 3, and I'm following this rule of translating up by x, what point would 4 comma 3 become?
Okay, so.
It's translating up by x. See a lot of silent groups when I asked you to take 30 seconds to talk.
What?
I was wondering.
7.
You don't have to memorize. I literally just asked you to get the point. Now, if you understand it, what point is that?
Am I, but are we forgetting, am I going
Wait, it says
I asked you to translate 4 comma 3
x is
up by x.
So.
up is,
Oh!
Okay?
I know what it is.
Oh.
Hold on.
no.
Alright, Aaron, what'd y'all come up with? Aaron, what'd y'all come up with?
Let me do it, I got it.
Is your name Aaron?
Oh, I mean, yeah, no, I went ahead and.
Have y'all talked about it as a group?
Not, it's on 30 seconds.
That was way more than 30 seconds.
I don't know. But go
We
on.
don't even get a chance to think.
I was saying, but I have an idea.
What do you think, Kyle?
I don't know. Oh, no, for, I think 4 comma 7.
Anthony?
I think you're 7-3.
Yeah.
7-3?
You said that
You ain't say nothing about
you
the
only
Y.
went up, but it's,
I thought this was, the whole thing was that this was a vertical translation of x.
Cause I use that same formula
Wait,
that you have up there.
Oh
F
my
of x
God.
equals 3 plus x.
Anthony?
If it's vertical, then it's only on the Y axis, but it's talking about
No,
vertical.
it's only in the y values. It's a vertical translation of x. That's the way it's been the whole way through.
Oh, so yeah, 7-3.
7-3 would be over here. Is that vertical?
No.
would you go,
So 3-7.
So 3, 7 would be up here. Look at those blue points. Does that match those blue points?
No.
No. Anthony, why are you changing the x value? Let me ask that.
Cause it's saying the vertical translation of it.
Yeah, if it's vertical, does that affect the x values?
He thinking about,
Cause it said of X.
Yeah, that's what I'm
that's
saying.
why,
Okay.
that's why he trying.
But listen to my question. If it's a vertical translation,
It's the Y.
does it affect the x values?
No.
No, why?
So then why are you changing the x value?
Cause of the of X.
It's a vertical translation, Anthony.
So we don't even look at it of X.
No, the x does matter. Because it's a vertical translation by what?
By
X.
By x. So, we're starting at 3, and we're adding what to it? The x, and what is the x?
4.
Okay, but does the x change?
No.
No. So the x is still 4, but the y is,
7.
thank you. So I have to approximate it to here. It's a vertical translation by 7. Okay? Let's look at negative 2, 3. Talk about it with, I want you to take 30 seconds to think on your own. And I'll tell you when that's up, 30 seconds to talk as a group to figure out what point that would become after a vertical translation of x. Talk as a, think on your own.
Oh, that's easy.
Talk about it as a group.
I don't know, Mr. Ken.
It's a translation by x.
What we do?
It's a vertical translation of x. Alright, talk with your groups. Figure out what that point would become. Alright, Caleb. Are any of those points, or is any part of this point going to stay the same? No idea. Let me ask you this, Caleb. If it's a vertical translation, which variable is associated with the vertical?
Y.
So is anything happening to the x? So is anything staying the same?
Yeah,
What?
X,
Yes, the x is going to be
Negative.
-2.
negative 2, 5.
Okay?
How do you get?
Negative 5, I mean.
No.
Yo.
Negative 2 plus 3.
It's
Negative 2
one.
plus 3.
Negative
Now, hold on. I'm not saying you're necessarily wrong, but I want you to think about this first off. Y'all are forgetting that we're starting with what number? 3. And then we're adding to it the X.
Value.
So it's really 3 plus
-2.
-2.
Oh.
And what is 3 plus that -2?
1.
1. Oh.
So it's -2, 1.
Yes.
Oh.
Yes. That's just
-2, 6 would be all the way up here.
I enjoy this.
So not that. Remember, what are we doing? We are adding X. That's my X, correct?
So we.
So I'm taking the 3 and I'm adding the X value to get the new Y value.
So 3, I always gonna add by 3 by 8.
So,
I wouldn't even look at what 326 is. That's why.
but that's why it is a vertical translation of X. Vertical is only affecting the what? The Y. And if it's only a vertical translation of X, I'm only affecting that Y value by X. They're being added. That's it. So one last one. Let's look here at -5, 3.
Okay.
I want you to talk about it within your groups, come up with an answer of within 45 seconds of where that point, -5, 3 will be.
Wait, what? I can. Wait, what was the point?
-5, 3. Where is that point going to be after the vertical translation?
Oh. I got it now.
You don't know. Yeah.
That's what I got.
So basically what we doing is we just substitute that
Cause,
that Y value back.
We'll talk about it in a second. Alright, Mitria, what'd your group come up with?
-5. 3 is got that.
Did y'all talk at all? Come up with anything?
-5,
-5, -2? Is that what you agree with, Dawson?
Yeah.
Yeah?
I said it out loud.
Oh, it's all about you?
Yeah. Go say it out loud.
Now,
So sick.
what I want to point out is, it's not just looking at one thing. First off, can you look at this equation to help you figure out just 3 plus whatever the x value is? Yes. But also, if you look at the points, can you just take that 3 and add the x value to it?
That's exactly what I did.
That's all it is. But notice, they're going together. Now look at this graph. What kind of function is that?
Linear.
Linear. Ishmael, what's the y-intercept of this linear function? Do you have it graphed on your paper?
Oh, we supposed to grab.
Take 10 seconds to graph it.
He's so bad, y'all.
Y'all killing me.
That was something.
The y-intercept is 3.
I ain't grabbed it. Oh.
3, 0, 0, 3,
Ishmael, do you agree that the y-intercept is 0, 3?
Cause that's where the line started at.
Come on.
Be careful. A line that goes for infinity is where the line
That's what, yeah,
intersects the
Yeah.
Y-axis.
y-axis, okay? So the y-intercept is 0, 3. Destiny, what's the slope of that blue line? The transformed line?